Alright, these are the video notes for the Big Ideals book, the Geometry section 4.2. Today in this section we're talking about a reflection. A reflection is where a figure is reflected over a line. The line is called the line of reflection. This figure should stay the same shape and the same size, but may look slightly differently because of the reflection. Alright, so let's take a look at this. This says to graph triangle ABC with vertices of A being at 1, 3. So we're going to put point A there. B is at 5, 2. So there is B. And C is at 2, 1. There is C. So this is triangle ABC. Now it wants us to reflect it over the line x equals 3. Now think about this. The line x equals 3 is that horizontal or vertical. Hopefully you went ahead and you said that this was a vertical line. And it goes through the x-axis at 3. So this is the line x equals 3 right here. So now I'm going to put my new picture in purple. So if we reflect each point, think about A. A is 2 units away from this line. So we go 2 units on the other side. This is the new A. I'm going to call it A prime. B is 2 units away on this side. So we're going to go straight across 2 units, and we're going to put B over here. Now C is 1 unit away, so we go 1 unit on the other side, and C prime goes over there. Now if you look at this, it is an exact mirror image of the other one. If you were able to fold on this line, this x equals 3 line, you were to fold it, the sides of the triangle would land exactly on top of each other. It would be a perfect reflection. Let's take a look over here. So this is the exact same triangle. So this is the triangle A is at 1, 3. B is at 5, 2. And C is at 2, 1. So it's our exact same triangle. Now this wants us to reflect over the line y equals 1. Now y equals 1 is going to be a horizontal line going through the y-axis at 1. So it's going to be this. So if we could just fold our paper going down and flip our triangle over here, that's essentially what we're doing. So look at this. A is 2 units above this line. So we go directly down and we go 2 units below. Here's A prime. C is on the line, so C actually stays for its reflection. C prime stays right where it is because it is on the line. B is 1 unit away from the line, so we just come directly below it 1 unit, and this is B prime. And this is our new reflected figure over the line y equals 1. If you look, it's a mirror image directly over this line. Alright, so we don't always have to just use counting because sometimes it's not as simple. It's fairly easy if it's over a horizontal or vertical line such as the x-axis or the y-axis or any other general horizontal or vertical line. But if it's over a line like y equals x or like y equals negative x, then it's a little more difficult. So that's where these rules come into play. So I'm going to go ahead and write these also in mapping notation. You might want to find this page in your student journal and also just jot this down. So basically, if I have the point AB, and if I am reflecting over the x-axis, then my point A stays the same, but B becomes negative. If I am reflecting in the y-axis, then exactly the opposite is true. So my point B stays the same, but my point A, which note is in my x spot, turns negative. And this will make more sense as we actually do problems. If you reflect over the line y equals x, then your point AB simply switches order and becomes BA. And if we're reflecting over the line y equals negative x, then our point AB not only switches order, but also changes sign. So let's try using some of these. Alright, this is in your student journal on page 100. I went ahead and drew in the triangles just to help kind of keep the length of the video down. So if you would like to pause this video and go ahead and draw in a triangle ABC in each of the problems 1 through 4, then I would do that now. But I'm going to go ahead and show where the reflections are at. Alright, so on number 1 it says we're reflecting over the y-axis. So the y-axis is this line right here, and that's what we're reflecting over. So we can sit here and we can do counting just like I showed you earlier, or we can use some of our rules. So if we remember, the y-axis said we go from point AB to negative AB. So think about your point A, which is negative 1, 5. When we go over the y-axis, we are going to keep the -1, but now it changes sign. So this is the same as saying negative, -1, which just turns it to positive. B stays exactly the same. It's the same number and it's the same sign. So this negative right here is just changing the sign of the x-coordinate of the point. So A prime is 1, 5. So if we go over and we say, okay, 1, 5, this right here is A prime. Now B was -4, 4. So it does the same thing. The x-coordinate, the -4, changes sign. The y-coordinate stays the same. This is my coordinate for B prime. So I go 4, 4, and this is B prime. C was -3, 1. So once again, the x-coordinate changes sign. The y-coordinate changes exactly the same. So the x-coordinate became positive. The y-coordinate stayed as 1. So it's now +3, 1. So this is C prime. And if we draw on the triangle, we can tell it's a perfect reflection over the line over the y-axis. Let's do this one over the x-axis. So this is the x-axis. This is the line it's reflecting over. Once again, let's use our rule. So if you go back in your notes, you're going to see that when it's reflected over the x-axis, point AB just changes, and it is A, -B. So that means this coordinate in the x spot stays exactly the same, but the coordinate in the y spot switches its sign because it is reflecting over the x-axis. So however high it was, it's now that distance below. That's why it changes sign. So if we look at point A was 0, 2. It now becomes 0, -2. The x-coordinate stays the same. The y-coordinate switches signs. B was 4, 5. It now becomes 4, -5 because the x-coordinate stays the same. The y-coordinate switches signs. C is 5, 2 because it becomes 5, -2 because the x-coordinate's the same. The y switches signs. So let's graph it and make sure it makes sense. So 0, -2, that's now A prime. 4, -5, that's B prime. And 5, -2, that's C prime. So if we look at this, does this look like a reflection over that line? I would say it does. So now we're going to look at over the line y equals 1. Now this one, you can somewhat mathematically do this, but really the best thing to do is sit here and graph it. Y equals 1 is going to be a horizontal line going through the y-axis at 1. So in our case, since I went by 2's, it needs to go right here. Keep in mind that I went by 2's on these graphs because they were smaller graphs. Personally, on these type of numbers, I probably go by 1, but I'm just going by what the student journal gave us to work with. So if we go here and we look at A is at 2, -1. So it is 1, 2 units below the line. So we need to go 1, 2 units above the line. So this is A prime. C is from this line. Remember, half of a square is 1 unit. So it's 1 unit, 2, 3, 4 units away. So we want to go 4 above. 1, 2, 3, 4. And so this is C prime. B is 1, 2, 3 units below. So we want to go 3 units above. Remembering that the lines are worth 2 units because I went by 2's. And so that is our new triangle. Over here, this one is a vertical line at -3. So I'm going by 2's. So 1, 2, 3. So this line, x equals -3, is right there. So now if we cross this line, once again, this is 1 unit away, so we go 1 unit away. This is A prime. This is 1 unit away, we go 1 unit away, this is B prime. And this is 1, 2, 3 units, or a box and a half. So we go 1, 2, 3 units, or the equivalent of a box and a half. And if you look at it, it is reflected over that line. This is also the line of symmetry. So if you were to fold this paper along this line, then the two triangles should lay exactly on top of each other. Okay, so let's go ahead and look at the next section. This one is kind of similar. I just wanted to make sure we understood. This is the line y equals x, which we didn't really see a great representation of. So first I'm going to graph FG. This is not in your student journal, so you can just sit back and watch and make sure you understand the general concept. So F is -1, 2. That's right here. And G is 1, 2. Alright, so this is FG. Now, the line y equals x is the line that goes through 0, 0 with a slope of 1. So if we go right here, that's our line y equals x, and that's the line we're reflecting over. Now, these reflections are a little harder to just picture, so this is where our rule comes into play. And our rule was that if we have point AB and it's reflected over the line y equals x, then its image is BA. So we basically switch the coordinates. So if f is negative 1, 2, we're going to switch the coordinates. The new point is going to be 2, negative 1. If g was 1, 2, the new point is going to be 2, 1. We just reverse the coordinates. So let's see what this looks like. If we have 2, negative 1, this is f, and then if we have 2, 1, this is g. Now, it may look a little weird, but if you think about folding along this line, like folding your paper kind of at an angle over this line, then these would line up perfectly on each other. Because if you look at it, this distance right here is the same distance as this distance right here. And we're always looking at the distance kind of perpendicularly to the line. But that is why our coordinates switch. So as long as you know rules such as this, the rules on that previous page where we had 4 of them, those are going to carry you through your whole assignment. Alright, this would like us to graph the image after the reflection over the given line. So keep in mind that it is asking us to go over the line y equals x. So that is where it has a slope of 1 and goes through 0, 0. So I would stop and I would draw in this line onto your graph. Now if we think about this, point A is the point negative 3, 2. Remember that when we're reflecting over y equals x, our point simply switches to where it becomes the y coordinate comes first. So A prime is going to be 2, negative 3. Okay? So instead of A being at negative 3, 2, now we have 2, negative 3. So this is where A prime will be. Alright, for B, B is at negative 1, 2. So when we switch the coordinates, B prime is at 2, negative 1. So over 2, down 1, that is where B prime is at. Alright, let's look at C. C is at negative 1, 4. So C prime will be at 4, negative 1. D is at negative 3, 4. So D prime will be at 4, negative 3. So let's go ahead and graph C. C is there, and D is 4, negative 3. D prime is there. So if you look at this, that is a beautiful reflection over the line y equals x. And this line right here is the line y equals x. Alright, let's go ahead and try that again, but let's do over the reflection of the line y equals negative x. So if you think about where that line is, that is the same line except it's going to be slanting downwards. So we're going to come over here, and that line has a slope of negative 1, but it goes through the point 0, 0. And so that line right here is y equals negative x. Now our rule, you may have to go back and look at, but it's a little different. Instead of just doing BA, we do negative B, negative A. So the points not only reverse where they're at, but they also change sign. So let's go ahead and look at our points first. A, B, C, D. A is at the point, keep in mind this is going by 2's, so it's at the point 2, 0. B is at the point 5, 3. Once again, it's going by 2's. C is at the point 2, 5. And D is at the point 1, 4. Alright, so when we want to find A prime, B prime, and C prime, we not only have to switch the order of the coordinates, but we also have to change their signs. So 0 comes over here and 2 comes over here. Now 0, you don't put negative 0, but 2, you do put negative 2. So you're changing its signs. So now over here, this is 5, 3, and so you now switch it, and it's negative 3, negative 5. And then C becomes negative 5, negative 2. You're switching the order and the signs. And D becomes negative 4, negative 1. So if we graph those, we have A prime was 0, negative 2. So that is now down here. This is A prime. B prime is negative 3, negative 5. That's now right here. C prime was negative 5, negative 2, which is right there. And D prime is negative 4, negative 1, which is roughly right there. So if we take a look at this, it looks like a fairly decent reflection. All right, real quick, I just want to state a reflection is a rigid motion. So as you've noticed, our reflections aren't enlarging, they're not stretching, they're not changing shape or size, they're simply moving, okay? They may look slightly different because they have been reflected, but overall, the area is the same, the perimeter is the same, the side lengths stay the same. Nothing changed. All right, so on this one, this is just another example, also not in your book, but this is a composite, okay? So we're doing two things. We're translating it and we're reflecting it. I went ahead and drew figure ABC just so we could see, but let's go ahead and see what it is after we translate it. Now, these points would be moving to the left. So if we just go ahead and find A prime, B prime, C prime after the translation, we go ahead and do that. Now keep in mind that since it says Y, the Y is not changing. It's still 2, this is still 3, this is still 1. The X we need to plug in. So if we plug in 3 minus 3 minus 12, and then 3 minus 12 is going to be negative 9. If we plug in a 6, 6 minus 12 is going to be negative 6, and plug in 7, 7 minus 12 is negative 5. These are your points after the translation. Alright, so now we're going to go ahead and do your points after the x-axis. So remember that when you reflect over the x-axis, your point, A, B, X, Y, however you want to look at it, simply all that changes over the x-axis is that A stays the same and the B changes signs. So our new point for point A, point B, and point C, point A, we keep the negative 9. We're going from this point, from A prime to A double prime. But we change the sign here. So it's negative 9, negative 2. So here we keep the negative 6, and then we change the sign. So it's negative 6, negative 3. Keep the negative 5, change the sign. So it's negative 5, negative 1. So we are moving this left 12, and then we're reflecting over the x-axis, which is right here. And so we're going to have a point at negative 9 and then negative 2. So that's going to be A double prime. And we're going to have negative 6, negative 3. That's going to be right there, C double prime. And negative 5, negative 1, which is, that one is C double prime. Alright, and so that triangle, we have slid it this way 12 units, and then we've reflected it by flipping it over the x-axis. And this is our final triangle. Keep in mind, it's also a rigid motion because the translation was rigid, it didn't change shape or size, and the reflection was rigid, it didn't change shape or size. So when you put them together, they still do not change shape or size. Alright, so in your student journal, on page 101, we have these. Once again, I went ahead and drew in triangle JKL just to help make the video a little bit shorter. So feel free to go ahead, pause if you would like, and draw in JKL on both number 7 and number 8. Alright, I'm going to look after the translation. So after the translation, I'm going to sit here and I'm going to do x minus 6 and y minus 1. So if I plug in, this should be a j. If I plug in to j, and I plug in 3, 3 minus 6 is negative 3. And if I plug in 1, 1 minus 1 is 0. Now I'm going to go ahead and do so for k and l. Alright, so on k, if I plug in 4, 4 minus 6 is negative 2. I plug in 2, 2 minus 1 is 1. On l, I plug in 1, 1 minus 6 is negative 5. And I plug in 3, and 3 minus 1 is 2. So this is after the translation. Now I want to go ahead and I want to do the reflection. So this is a composite. We've done a glide reflection. So we glided it one way or the other, and then we've reflected it over something. So reflection is over line y equals negative x. So remember, going back to your notes, you're going to take your points, A, B, and you're not only going to switch them, but you're going to change the signs of both. So j double prime, after we've changed it from j, we're reflecting it from j prime to j double prime. We're not going back to the original points. So we're going to switch them, and we're going to, if they're positive, make them negative. If they're negative, make them positive. So we're going to put the 1 over here and make it negative, and the 2 on the other side and make it positive. On L double prime, we're going to put the negative 2 over here. We made it negative, and the 5 over here, we make it positive. So let's go ahead and graph this. This is at 0, 3. So that's going to be right here. And then k is at negative 1, 2. And so that's going to be right over here. And then it's at negative 2, 5. So we go back to sorry, and up 5. Okay, so this looks a little crazy, but what we've done here is we've not only slid it to the left 6 and down 1, but we've also reflected it over this line. This line, oops, I'm sorry. This line right here is y equals negative x. So I'm just going to check real quick and make sure that I did that correct. Just kind of looks funny. So we did negative 3, and we did 0, that's great, and then we switched it, and we did 0 and positive 3, 0, positive 3, okay, that's fantastic, and then we did negative, we plugged 4 in and got negative 2, and plugged 2 in and got 1, and then we switched them, and we had negative 1 and positive 2, alright, that looks fantastic, and on L we plugged in 1, we got negative 5, we plugged in 3, and we got 2, and we got negative 2, 5. Alright, as crazy as it looks, that is the correct one. So let's check this out real quick. So same thing, let's do J. We're going to plug in our points into this right here. So on J, our x is going to stay the same, so it's still 3. Our 1 plugs in, and 1 minus 4 is negative 3. On K, our 4 is the same, but then our 2 plugs in, and 2 minus 4 is negative 2. And on L prime, our 1 plugs in and stays the same. Our 3 goes 3 minus 4, which is negative 1. Alright, so this is after the translation. Now let's do after the reflection. X equals 1. So let's go ahead and graph these real quick and see what they look like. Make sure we feel like they're okay. So 3, negative 3 is going to be right here. That's going to be J prime. And then we're going to have 4, negative 2 is right here. That's going to be K prime. So yeah, let me go ahead and leave my letters off until I see where my shape moved. So 4, negative 2 is K prime, and then we're going to have 1, negative 1 is L prime. Alright, so that is after just the translation. So now I want to reflect it. Okay, I'm going to reflect over the line x equals 1. Keep in mind the line x equals 1 is right here going down that way. So when I reflect it, I'm going to go ahead and just switch to orange here. This will stay the same because it is on the line, so L double prime stays there. J is 2 units away, so we go 2 units away to this side. K is 3 units away, or a box and a half, so we go over to this side. So this is K double prime and J double prime. And that is our figure. It is translated down 4 and then reflected over the line y equals x. And this orange figure is our final answer. Alright, this should look pretty familiar. This is how many lines of symmetry does each hexagon have? So line of symmetry is where if you fold down this line, the sides should all fold on top of each other. So if you look at this line of symmetry, I feel like it has one here. Sorry, my lines are getting a little crooked. It has one over here. Now think about it. Does it have one, I'm going to use my line tool, does it have one right over here? What do you think? This one right here. I'm going to go ahead and kind of change the order. Alright, so is this a line of symmetry right there? If you folded it, would it work? That's what I want you to kind of ask yourself. It wouldn't work on this one, so we don't want to count that as a line of symmetry. Okay, so if you look over here, there's a line of symmetry. Here is also a line of symmetry. Sorry, pretend it's going through the vertex. Here is also the line of symmetry. Then, in addition to those three, if you look at this, if you did this, is there a line of symmetry? Yes, there is. What about this? Yes, there is. Over here, there is also. So this one actually ends up with 6 lines of symmetry. Now over here on this one only has 1. Right here, this has 1 line of symmetry. So it's symmetrical when it's reflected over that line and is the exact same shape. Alright, this is in your student journal once again. So it wants us to know what the line of symmetry is, if any kind of the word. So if we go and we take a look at this, the word moon. So we're kind of looking to where, if any, is there a line that I could fold this over and be symmetrical. So if you folded it straight in half, the O's would line up, but the M and N would not. If you folded it horizontally this way, then it would still not line up because of the M and the N wouldn't look the same. So this has no lines of symmetry, so we're going to put none. Now, wow, if I drew a line straight down the O, if I folded over this, do you see how the O would land on its other half and the W would reflect over here? That has a perfect line of symmetry right there. Kid, if you look at it, if you fold it in half, the K will fold over on itself, the I will, and the D will. It will match up perfectly. So this has one line of symmetry. And then Doc does also, because the C and the K, the O, and the D will all fold over onto themselves. All right, so check this out. This shows that you have two computers, and line W here is the wall, and you want a power strip to connect the two computers. So it says, where should you place the power strip to minimize the length of the connecting cables? So basically, where would the shortest place be? All right, so if we went ahead, I know like you guys are just going to say, Miss Levan, it's halfway in between, but we actually do want to go ahead and find it mathematically. So if we went ahead and reflected computer A right here over this line to get computer A prime, so after it was reflected, this isn't perfect, but just looking at it, okay? So then if we had a segment, instead of from A to B, we have from B to A prime. So this is from B to A prime. All right. And so if we call this intersection right here where the line intersects point C, I'm just going to call it right there where this line intersects the wall, because obviously, technically, we can't have that computer on the other side of the wall and still use a power strip. All right, so from B to A prime, all right, that's the shortest distance in between. And from, if we did A to C, then this distance right here, from A to C should be the same distance as this distance from A to C, okay? So if we put this power strip here, it would minimize the distance. The reason you can't just be like, hey, halfway in between there is because the wall is over here, which obviously is where the outlet is. We're not assuming it's a room where you have outlets in the floor. So this is kind of more of a theoretical question. It's nothing you should get stressed about. It's okay if you didn't completely understand it. As we do some projects and really use the math and kind of simulate some examples, it will make a lot more sense. We're just kind of getting a feel for how it works. Right now, though, if you've mastered using the rules to do reflections and translations, you're off to a great start. All right, the last question I want to look at is, it says, the reflection of triangle CAT is triangle C prime, A prime, T prime. The two triangles have the same perimeter. Why should they have the same perimeter? So that is because a reflection is a rigid motion. So remember, what that means is that the sides don't change, the shape doesn't change, the area, the perimeter, none of those things change. It is a rigid motion, which means it is not changing shape or size. All right, thank you for listening. Tomorrow we will do the 4.2 homework in class and hopefully get it all done.